this starts to get to the question you had about geomagnetic latitude and longitude. So we're going to talk about NERC for just a second. So, okay, presidential executive orders are in place. Congress hasn't done anything meaningful, or at least the government hasn't responded to it. So what about NERC? What about the Department of Energy? All right, let me show you real quick. This is a visual representation of the NERC GMD standard. This is the solar storm standard established for the protection of the grid against the ground-induced currents caused by solar weather. Okay, it was developed after the 1989 Hydro-Quebec storm, and it has a benchmark of 8 volts per kilometer, which would be up in the northern latitudes. Okay, because when it comes to solar weather, the ground-induced currents produced by a solar storm, in general, as you come down from north to south, the threat is less in general. Okay, a lot of factors though. Ground conductivity is a factor. There's something called the coastal effect. If you're near the coastline, where the ground is more conductive, so it's an in general principle. Unfortunately, when it comes to high altitude nuclear EMP, it's the inverse. Closer to the equator, the more profound the effect. Okay, regardless, NERC has a benchmark they established, which is way up there next to Canada. And then their standard was designed in a way that you scale down as you go further south. So when I was briefing Secretary Granholm on this, I was explaining to her that in Washington, D.C., with that scaling factor, they need to be protected at 2 volts per kilometer. What does that mean? It means you have to do absolutely nothing to protect the grid. That's how the standard was designed. I'm just going to say it. Okay, designed so you have to do absolutely nothing. Here's the realistic threat though. We know 1921, the railroad storm generated about 20 volts per kilometer in terms of field strength. This is the 18, and when I say railroad storm, why? Because there was railroad infrastructure that literally caught fire from the sparks that came from the telegraph machines. 1859 Carrington superstorm, you may have heard of that, solar storm. We don't know, we didn't have magnetometers at the time. So, but we know it was pretty bad. Remember I told you about Kazakhstan and the Soviets nuking above their own people? 66 volts per kilometer is what they achieved. That's the data we got. So this is the realistic threat. This is the benchmark. This is the level of protection in Washington, D.C. Now, I pleaded with Secretary Granholm on 4 occasions, and her entire advisory board pleaded with them. Please, please. The infrastructure bill, $1.2 trillion. Nationwide, you could fix this for just over $4 billion. That's 1/3 of 1% of that bill. How much was spent?
Do you have any sense of like the solar storm or whatever the right thing to call it, what happened last year? The large far south things.
I do.
Where that hits in like the scale.
Yeah, so perfect question. We're going to get to that, and the guy's going to answer it. The question was, what about the May 10th solar storm last year? Where does it fall here? And the answer is way below this. Yeah, and Dave Anderson, who's on, is going to tell you the story about what they, because their stuff was actually sensing it and working at the time. Look, this is really depressing, but it doesn't have to be. Okay, there's like really good news at the end of this. Okay, I promise you. What's that?
Welcome to the utility.
Right. Yeah. All right. So here's Texas. Let me just real quick show you. It's not any better in Texas. Okay. Specifically when it comes to hemp E3, because that field strength gets stronger as you go down in geomagnetic latitude. What the Department of Defense found, and they declassified this in 2017, is it's really about an 85 volts per kilometer field strength that you have to worry about in the southern latitudes of the United States. This is why actually the IEC standard for this will soon be updated to 100 volts per kilometer. That's coming. Dave Anderson can talk about that because he tracks and all that. But this is the declassified report that says that 85 volts per kilometer is the field strength we have to worry about for hemp E3 in the southern latitudes of the United States. This is what y'all had asked about with the solar weather. So when you look at the NERC standard and that scaling factor I just talked about, that's the diagram, right? So when you come to Texas, you see it's right middle of Texas is 0.8. DOD is saying you're looking at about 85, which you worried about for hemp E3, right? The good thing again is if you protect against this with the technology you're going to hear about, you protect against both the solar weather and the hemp E3 part of it. This is what it looks like though, as far as just the visualization from the NERC benchmark, where you're at right now in Texas. If you follow the NERC benchmark, which means you do nothing, and then the real threats, right? So where are we at in Texas from a policy perspective? Great story about how we met Senator Hall. Tribute that to God. we've had a lot of legislative sessions to try to address this. It's failed every time. When I say this, I mean electromagnetic spectrum threats, right? I'm not talking cyber, supply chain, physical sabotage, terrestrial weather, any of that stuff. I'm talking about electromagnetic spectrum threats. Any attempt legislatively has failed so far. To me, that was really depressing, okay? But the good news is that while all that was happening, we had Texas-based utilities and innovators coming up with technological solutions, which you're gonna hear about in just a minute, to actually protect against this. So 10 years ago, we didn't have solutions that we could immediately say, hey, there it is, this is what it costs, and it's been tested, right? And so the good news is that despite these efforts, the other thing is to know that the people have been briefed, right? People know, okay? I've personally briefed from the top all the way to right here to the people, everybody I can get my hands on briefing. So it's not like we don't know that this is an issue. The good news is that over the last year, I feel like we've made a lot of progress. And I feel like look, yesterday we had a whole bunch of brand new, they are called freshmen, although I never want to call them that myself because I wouldn't consider them, but brand new legislators in the Texas House that came and got briefed because they wanted to, they were interested. And they came away saying, man, let me know how I can help.